As I promised in a previous video, I'm going to show you how to teach a vehicle to pick up components in the 3D world. The first thing you need to do is add a component container to your vehicle. I'll reset the simulation, zoom out, and select the mobile robot in the 3D world. Make sure you're in the Modeling tab, and in the Component Graph panel, I'll select the root node. I'll now go to the Geometry group here and add a frame feature. Using the Move tool, I'll drag or snap the origin of the frame to the top face center here of the block. In the Feature Properties panel, you can see either in the world or parent coord system, that's 50 for the X and Y axis and 100 in the Z axis. This will be the location of our container in the vehicle. I'll now go to the Behaviors drop-down menu here, and under Material Flow, I'll click Container to add a component container behavior. In the Properties panel, I'll set the location of the container to be at our frame feature. Let's now zoom out and access the script of our vehicle. I'll make the text bigger. Let's move our script over here to the right. And we don't need to see the component graph panel anymore, so we can unpin that panel. And now let's move our global variables down to the bottom of the script, so we're cleaning up. I'll cut them and then paste them after our onRun event. There we go. Let's now get a handle for the container in our vehicle. I'll write container equals comp.getBehavior, and the name of the behavior is component container. One thing I do want to mention is that when I say the word vehicle, most of the time I'm referring to the actual component itself or the mobile robot. So don't get confused about the words that I'm using, sorry. For our container, this is a type of VC container. It is a static container. So you can transfer components into the container, you can put them there, but you can't move them out of the container like a path, for example. So parts don't move in and move out of the container. It's static. And like I said, it does have an input and output ports. So you can transfer parts in, but the output port is kind of redundant. You can't really transfer parts out of the container unless you use Python API. And then in our script, instead of using the onSignal event to tell our vehicle where to go, let's use our onRun event. So let's clean this up. When we define the vehicle in the onRun event, let's suspend it. And we'll wait to get a signal from the conveyor to pick up a part. So instead of adding the control point here, I will just resume the run. And then after we resume the run, let's tell our vehicle to go to that point. So vehicle.addControlPoint. We define the point here in our code, and this is the point of the pickup location frame you can see in the 3D world. Let's now run our simulation and make sure everything works. So the vehicle is not moving. Here comes the part. Now the vehicle is going to the pickup location. Let's zoom in. And to pick up this part at the end of the conveyor's path, you can either use a grab or transfer method. And I will explain the differences between the two. Let's reset. And after our vehicle gets to the control point, let's create a delay using the vehicle's travel time. So vehicle.totalTime. And what we're doing is waiting until the vehicle gets to that location. Now, of course, you could use signals to make this stuff, really precise, but we're just using a test case here. Once the vehicle is there, let's get the part that's at the end of the conveyor's path. So I'll write part equals, I'll use the conveyor component object with its child components property. This gives you a list of components that are attached to the conveyor in the 3D world. I know that nothing is attached to the conveyor right now, so it's safe to assume that the child components are just the parts in the conveyor's path. And we want to get the first part that enters the conveyor's path. That's at the end. So we'll get the first item in this list. We then have the option to use either a grab or transfer method. Let's see how grabbing works first. So using a container object, you can call this method of grab. So this allows you to grab any component in the 3D world into a container, which we have got here in our code. We want to grab the part. And then after we grab the part, where do we want the vehicle to go? Let's actually tell it to go back to where it was before. I'll get the position matrix of the vehicle, so comp.position matrix. The vehicle is not attached to anything right now in the 3D world, so this position matrix is pretty much the same as the world position matrix. But let's just use the position matrix for now. And instead of using the current location of the vehicle, which will be here, let's use the identity. So I'll use the position matrix to call this method, because our position matrix is a VC matrix object, which can call this method. So with the identity matrix, let's now tell our vehicle to go back to a control point that is the position vector of the identity matrix for our vehicle. Compile the code, and let's zoom out and see what this looks like. So run the simulation, and the vehicle's waiting. Here it comes. The vehicle should grab the part and go back to where it was over here. And it does. Yep. So the vehicle grabbed that part in the conveyor's path. But you can see it is offset right now from the vehicle and the location of our component container. Now that happened because whenever you are grabbing a component into a static container, the part will retain its offset. So that's why the part is here, not here. So to fix that, let's just simply snap our part to the same location as our frame feature here in the vehicle. So let's reset. And now let's actually wait until the vehicle is at the pickup location, because you might be confused with how the offsets work. So let's wait till the vehicle gets close and then stop the simulation right here. Now, what is the distance between this part and our frame location here, where our container is? Let's go to the tools group here and take a measurement. So let's measure from the frame feature to where this part is. And you can see that's an offset of about 600 in the z-axis alone. So we want to get rid of that. And an easy way to do that is to go back to our script. And when we get the part, let's get its position matrix and set it equal to the frame feature of our container, its position matrix. So we'll use the container object to get its location property, which is referencing a frame feature. And I'll use the frame position matrix to be the new position matrix of the part that was grabbed. Compile the code, run the simulation, and now our part should be at the same location as our container in our mobile robot. Yep, there you go. So now, instead of the part being all the way over here, it's at the same location as the frame feature in our container. Now that's grabbing, but how does transferring work? Well, transferring, you can see right here, a part is created in the feeder, it's then transferred into the path of our conveyor. That's how transferring works. So let's reset, and this is kind of an easier way to grab components instead of having to work with matrices. So let's comment these lines of code out. We don't need them. Now, one difference between grabbing and transferring is that the component object itself can transfer it to wherever it needs to go, so to whatever container. So now we have to work with the part, and this is a VC component object that allows you to call either the transfer method or the transfer non-blocking method. Now the difference between these two is non-blocking will not wait until the part is in that container. It will just go on to the next line of code in your script. But we do want to wait, so we're going to use the transfer method. And let's actually check out the API reference to learn more about those. So you can go to your API reference guide, VC component, go to methods, and here you can find the information about those two. So for our part, we want to call the transfer method. And where do we want to transfer it to? Aha! The container that's in our vehicle. So we're going to pass the container as the first argument, and then what port do we want to transfer that part into? Well, we'll use the first port or its input port, which is an integer or index of 0. The output port would be, an index of 1. So let's use the 0 for the input port of our container. Compile the code, run the simulation. Here comes the vehicle. And yep, easy peasy. So we just transferred the part that was at the end of the conveyor's path into our vehicle, and it traveled over here. Let's now take a closer look at the path of the vehicle. So that's one good thing of having the swept volume here. We can see that the vehicle went in a straight line to the pickup location, but then as it was going back, you can see it kind of curved out and then create this separate lane here. Now that happens because we added the control point here in our script, but then we didn't replan or clear any past points. We just added a new point to the vehicle's path. So to avoid this issue, you can go back to your script, and before you add the control point, you can do like we did in earlier videos. We can call the replan method. Compile the code, run the simulation, and let's see the difference. Vehicle will go to pick up the part, and yep, you can see now we don't have that big long curve out here. Now it's just straight back. Another way to do this is to clear past points. So once the vehicle picks up the part, we already know it's at the first point we told it to go to. So instead of replanning the vehicle, we can just clear the past points by calling this method. And then the vehicle will just calculate the new path using this control point. Compile the code, run the simulation, and let's see if we notice any difference. And it's pretty much the same as the second example we saw. So you can either replan the vehicle, you can clear past points, you can add more points, you can also tell the vehicle to completely stop. So we can call the clear move and then give it a new path like this. So we actually could call this before we even pick up the part. And now if we compile our code, run the simulation, the only thing we're doing now is just completely stopping the vehicle once it gets to the pickup location, then telling it to go back to where it was. Yep, here we go. Now before I end the video, I want to quickly mention how you can rotate the vehicle to have a certain orientation at the pickup location. So let's reset, and before we go and grab any more parts, let's actually comment out these lines of code. And then once we know that the vehicle is at that pickup location, let's get the vehicle's position matrix. So I'll say position matrix equals comp.position matrix. Then from here, I'm going to get the axis angle of the matrix. So I'll say print pm.get axis angle. Let's now compile our code, run the simulation. We're just waiting for the vehicle to get to the pickup location here. Let's now check our output panel. And we actually got a vector back for the axis angle. So if you check the API reference, the axis angle, the rotation you're looking for is actually the W attribute, or the W vector of that matrix, or the vector object. So let's get the W attribute here, clear the output panel, run the simulation again. And now the vehicle is going into strike. And you can see it has this orientation at the pickup location. Go to your output panel. And I don't believe it actually printed the value. So I'm actually going to have to go back to my API reference guide real quick. Go to VC matrix. And let's go to methods. And this is the method I'm using, getAxisAngle. It returns a vector. And we want the W property for its rotation angle in degrees. because you can see here it's referencing that identity matrix, and that's why I was using this in the video, because it kind of ties into this orientation. So what is the angle of the vehicle relative to where it was in the beginning? So let's reset, and I believe it should be printing the value. Maybe need to just add some space here. Compile the code. And here comes the vehicle. And now let's see in the output panel. It's a value of about 44.79 degrees. And if you don't want to, do the matrix stuff, you can just select the vehicle in the 3D world, and if you go to the component properties panel and use either the parent or world coordinate system, there's that value right here for the rotation around the z-axis. So what we want to do is undo that value. So the vehicle, it's kind of flush with the x-axis of our pickup location. Let's go back to our script, and we can reset our simulation. And then, hopefully you know what we're going to do. We're going to rotate the vehicle in place, and we want to undo that angle of the vehicle that we have. So I'll say angle equals the position matrix of the vehicle, the axis angle of the vehicle relative to its identity matrix, which we know is about 44 degrees. That's what was printed here in the output panel. So we're going to take away that angle with a negative angle value. Compile the code, run the simulation, and now we expect the vehicle to rotate and line up with the x-axis here. And that didn't work, and I realized my mistake before even running the simulation. I forgot to add the other 3 arguments for rotating the vehicle. So let's reset. Sorry about that. Let's use 50 for the speed of the rotation, 50 for deceleration and acceleration. Compile the code, run it again, and now we should see the magic. I will leave that mistake in the video so you'll learn from it. And yep, there we go. And you can see with the mobile robot selected in the component properties panel, the rotation around the z-axis is now 0. So let's reset and now tie everything together. Let's uncomment this line of code here. We don't need to clear the move. It's fine for now, but we do want to wait until the vehicle is done rotating. So I'll create a delay here using the vehicle's total time for the rotation. We'll then get the part, transfer it into the container of our vehicle. We don't need the lines of code here anymore. And then for the position matrix, we already have that here. So now we can just get the identity matrix of that position matrix and tell the vehicle to go there. And that's our whole script. So compile the code. Let's zoom out and see how everything came together. Run the simulation. Here comes the vehicle. Vehicle rotates, grabs the part, and it did not go back to the original location. So let's see what we need to fix. We rotated the vehicle. Let's actually call the replan. So vehicle replan. Compile the code, and now it should work. You could either call replan or clear past points or the clear move again. It's fine. And yep, there the vehicle goes. It is going quite slow, I must admit, so let's see if we can speed this up. And since we're doing a rotation in the vehicle, I will give the vehicle a brand new path after we transfer the parts. So I'll use the vehicle object to call the clear move method. Compile the code, and if we zoom out, run our simulation, we want our vehicle to pick up that part. So it will go to the pickup location and it should rotate. It does. It now transfers the part and goes back to where it was before. Great. Let's now reset our simulation. In the next video, I'm going to show you how to use a transport protocol. A transport protocol will make it easy for the vehicle to know what it's supposed to pick up and where it's supposed to go.